So in part 2 of question 2, we're given an experiment that the student attaches a car to one another spring and to a force sensor that is attached to a wall. And we displace this car with mass of 0.25 kilograms, and we're given this velocity, time, and force time graphs. And in part C1, we need to use the data in the velocity time graph to calculate the change in kinetic energy of the car from t is equal to 5 seconds to t is equal to 2 seconds. So t is equal to 5 is here, t is equal to 2 is here. So we need to find the change in kinetic energy. So the change in kinetic energy is simply the final kinetic energy minus the initial kinetic energy. But we see that the final kinetic energy at 2 seconds is simply 0 because we have a speed of 0 there. So this will simply be minus the initial kinetic energy. So this will be minus 1/2, and then the mass is 0.25. Our speed is 0.3 squared. So if we plug this in, we will get this is minus 0.0113 joules. Then in part 2, by using the data in the force time graph, we need to estimate the change in momentum of the car from t is equal to 0.5 to t is equal to 2.5. We need to explain how we arrived at our estimation. And what we need to notice here is that the force, the net force, is simply equal to the rate of change of momentum. This is Newton's second law. And therefore, force times the change in time is going to be the change in momentum, which on our force time graph is the area underneath the graph, or the area under the graph. So what we see is that we have this negative area and this positive area. So if we would integrate along this area, or if we would find the signed area, this would be a negative area, this would be the same magnitude but positive. The total area would be 0, and therefore delta P is also equal to 0, because delta P corresponds to the area under the graph here. And then in part 3, we need to explain whether the data from velocity time graph confirm our estimation from part C. And well, what we see from part C2, so what we see from our velocity time graph is that at 0.5, we have a speed of 0.3. At 2.5, we have a speed of 0.3. So the speed is 0.3 meters per second in 0.5 seconds and 2.5 seconds. And we know that momentum is equal to mass times velocity. So the momentum is same at both times, which is in agreement with part 2. There's no change in momentum.